Sally wants to make an open box, meaning it doesn't have a top, with a square base and a surface area of 212 square inches. We want to know the dimensions that will produce a box that has the maximum volume. So let's draw a diagram first. So we have a box, and it has a square base. So the bottom's a square, meaning the side lengths are the same, but the rest of it's not necessarily square faces. So this height is going to be a different height. And there is not a top, so that side is not part of the surface area. So we're interested in finding the maximum volume. So the volume of a box would be length times width times height. So that would be x times y. That has too many variables. So we need an equation that relates x and y. And we know something about the surface area. So the surface area is 212 cubic inches. And surface area can be found by adding up the areas of all of the faces. So the area of the square base would be side times side, so x squared. So that would be x squared for the bottom. And then we need to find the other side. So let's look at this side. This is length times width, or base times height, so xy. I'm leaving space in front of it. So that's this side. But notice the other three sides, other faces, all have the same area, xy, because x times the height, and then this one, x times the height. So there are actually four sides that have area xy. So now we have an equation for relating x and y. So if we solve it for one of the variables, we can substitute back in the volume. It doesn't matter which one, but it looks easiest to me to solve this for y. So first I will subtract x squared. And then I will divide by 4x. So that gives me y equals 212 divided by 4 is 53. And the x is in the denominator. And then x squared divided by x is x. And the 4 is in the denominator, so I'll write that as 1/4 x equals y. And now we can substitute into the volume. So the volume will be x squared times y, which is 53 over x minus 1/4 x. It's a minus sign, make sure we can see it. Okay. Now, notice there's an x in the denominator. So I'm going to make myself a note right here because this will be important later, that at x equals 0. So when x is 0, this denominator is 0. The volume is undefined. That's important. So ultimately, we want to take the derivative so we can find the critical values. So I think I'm going to distribute this x squared first to simplify this function. I'll call it v of x because it's a function of x. So x squared divided by x gives me x. So this would be 53x minus 1/4 x squared times x is x cubed. Now we're ready to take the derivative. So the derivative is 53 minus 1/4 times 3, decrease the exponent, squared. So that gives me 53 minus 3/4 x squared. Forgot to pause and find the domain. So let's do that now before I do something else with the derivative. So the domain, not of the derivative, but of the original function, so right here we're talking domain, is what can x be? So x cannot be 0 because before we simplified, we had an x in the denominator. So x cannot be 0. I'm just saying that. We'll write it down in a minute. And then x also has to be greater than 0 to make this base non-zero base. And then if x gets bigger and bigger, y has to get smaller to account for this surface area, but that could go on until the height is teeny, teeny, tiny. So x actually has no upper bound. So x is greater than, but not equal to 0. So this is not a closed interval. So in the end, I'm going to have to check and make sure I have found a maximum that I want and not accidentally found a minimum. All right, so now back to the derivative. We want to set that equal to 0 and solve to find the critical values. So I'll subtract 53. And then divide by -3/4. So I put that into my calculator and rounded. And then we want to take the square root. So x is equal to plus or minus, because we took the square root of a square, 8.41. And now we want to make our table, and it's going to be x, and our function is v for volume. And remember, we're plugging the values into the original volume formula here. We're not plugging them into the derivative. And the lower bound is 0, but 0 is not going to give us a box. It's not included in the domain, so I can't actually consider 0 to be a critical value. So I'm going to plug in 8.41. I can't use the -8.41 because that's a negative value not included in our domain. So let's plug that into the volume right here, calculator problem, and we get 297.02 for the volume. And then I don't have an upper bound, so I don't have an upper bound of the domain to plug in. So it's a pretty boring table. It's only got one value. So we're hoping that what we found was a maximum. So let's check. So our two of our options for determining if we found a maximum or a minimum are to use the second derivative test, or to do sign graph analysis on the first derivative. So let's do sign graph analysis. You've got to pick one. So let's do a sign graph analysis. So we have a critical value at 8.41. We don't have a critical value to the right of that. 0 was another critical value. We didn't write it here, but we noted up here that the function is undefined at 0. So there's another critical value at x equals 0. It's important that I am aware of that when I'm making my sign graph, because I'm picking values to plug in. If I pick something to the left of 0, I'm not actually finding out what's going on near this critical value. So I have to pick something in this interval as my test value. So how about 1? And pick something to the right of 8.41. So how about 9? And we plug them into the derivative. So I'm just going to do that on my calculator. So I'm going to, let's see, here's the simplified version. I will plug 1 in there. And clearly, if I take 53 and subtract 3/4 times 1, I'm definitely going to get a positive number. And then we check 9, which is to the right of 8.41. So 53 minus 3/4 times 9 squared. So 9 squared is 81 times 3/4. It's definitely bigger than 53. So this is negative. So that means it's increasing before and decreasing after. That's going to mean this is a maximum here at that critical value, which is what we wanted. So the maximum volume is 297.02 cubic inches. And it occurs when x, so the base of the square, is 8.41 inches. And the other dimension, because the question asks for the dimensions, is y. So we find y using this equation that solved for y. There are other equations that also have x and y, but this one's really simple and it's already solved for y. So 53 divided by 8.41 minus 1/4 times 8.41. I'll do that in the calculator. And I find out that y equals 4.20 inches.